Good morning, students. Let us solve some problems. Phi is given as x squared y z cube plus xy squared z squared. Then we will have to determine del phi. So grad phi we are going to find out gradient phi at 1, 2, 3. So phi is given as this. And of course grad phi is nothing but del phi. So which is nothing but d phi by dx. D phi by dx, which is equal to, we'll differentiate with respect to x first. So when you are going to differentiate with respect to x, that will give you 2x y z cube plus y squared z squared. Okay. When you are going to differentiate with respect to y, and here x squared z cube, so x squared z cube. When you are going to differentiate with respect to y, that will give you 2x y z squared. So y squared, so multiplied by 2y. When you are going to differentiate with respect to z, that will give you 3x squared y z squared. So here you will have 2z, so you have 2x y squared z. So your del phi is nothing but this expression. Del phi is nothing but, so you will have to substitute for partial d phi by dx, partial d phi by dy, partial d phi by dz. We will have this expression, this equation. And what is asked? Del phi at 1, 2, 3 is asked. So del phi at 1, 2, 3. So for wherever you find x, you have to substitute 1. Wherever you find y, you have to substitute 2. And wherever you find z, you have to substitute 3. So you have 2 multiplied by 1, multiplied by 2, multiplied by 3. So 3 cube. So simplifying, you will have 108 here. Here it will be 36. So 108 plus 36 is 144i. Similarly for jth component. Similarly for kth component, so that will give you del phi, which is del phi at 1, 2, 3 is nothing but 144i plus 44j plus 78k. Now some properties of gradient. So del a plus b, which is equal to del a dot del b. Del ab, which is equal to a del b plus b del a, where a and b are some scalars, two scalars. Now find grade phi. The phi is given as, scalar function is given as this at 1 comma minus 2 1, as we have done the earlier problem, the same problem. So we have del phi is given by this expression, we know already. So del phi, we will have to first differentiate with respect to x. So that will give us 6xy, correct? Then this will be, there is no x here, so 0, plus 3x squared minus 3y squared z squared. We have differentiate with respect to z, will give you this. Okay. Now simplifying will give you 6xyi, 3x squared minus 3y squared z squared j, and this term. And del phi at 1 comma minus 2 comma 1 will give you 6 multiplied by 1. Instead of y, you will have to substitute minus 2. Then instead of x, you will have to substitute 1 here. Instead of y, you have to substitute minus 2 is at 1. And you can simplify. So that will give you minus 12i, correct? This becomes 3 minus, here it is 4, 4 3s are 12. Okay, so you have minus 12. So 3 minus 12. And this becomes 8 multiplied by 2, that will give you 16. So minus into minus plus, that will give you plus. So we have del phi at 1 comma minus 2 comma 1 will give you this equation, minus 12i minus 9j plus 16k. Now phi is given as this, we will have to find out now grad phi. Del phi, we are going to find out del phi. So as usual, we will have to differentiate with respect to x, we will have to differentiate with respect to y, and differentiate with respect to z. When I am going to differentiate this log x, that will give you 1 divided by x square plus y square plus z square, and we will have to differentiate with respect to x, so that will give you 2x. So 2x times I. Similarly 2y times I j, 2z times k, combining all those things. So just take the common term out, so that will give you 2 divided by x square plus y square plus z square, then xi plus yj plus zk. So that's a mistake here, this is zk. We know already this is a position vector, and we know already this is nothing a position vector. So your r vector. So r vector can be written as this. modulus r can be written as this. So you have r squared equal to x squared plus y squared plus z squared. So we know the expression, this expression del phi. So 2 divided by, instead of this we will have to substitute r squared. And this is nothing but the position vector expression. So r vector. So your del phi equal to 2 divided by r squared, r vector. So that's the answer for this. Divergence and curl. Scalar product or dot product of two vectors, A dot B. So this is A is given as this and B is given as this. So you have A vector A1i plus A2j plus A3k. Similarly, B vector can be written as B1j plus B2j plus B3k. So now A dot B, that will give you A1b1 plus A2b2 plus A3b. So it's a scalar. The resultant of A dot B will be a scalar. What is the vector product? Vector product A cross B can be written as ijk, your A1, A2, A3 and B1, B2, B3. So that will give you this expression, and the resultant of this will be a vector quantity. Divergence means that you are diverging the fields, especially this will be used in magnetic field. In magnetic field, divergence of magnetic field will be always 0. Suppose if it exists, then there exists a monopole, and we know that monopole doesn't exist. So divergence of any magnetic field will be 0. And similarly, curl, when you are going to take a curl is nothing but a rotation or a swirling. Okay, so it's something like that. Okay, so we have a vector quantity and this must be a scalar quantity. So physical significance of gradient, divergence and curl. The physical signification of gradient of a scalar field can be stated as follows. Gradient of a scalar field at a point represents the maximum rate of change of scalar field with respect to the position, and it is always directed along the normal to the field surface. So it will be always normal to the field surface at the point. The gradient of a scalar function, which is nothing but it's a derivative or rate of change of multivariable function which is a component for each direction. So we'll have to differentiate each with respect to x variable, x and y and z. So del phi can be written as d phi by dx times I, d phi by dy times j, d phi by dz times k. So this can be abbreviated as sigma I del phi. So we can say d phi by dx, summation over I d phi by dx. Div f. So the expression for del is nothing but this, and the expression for your vector field can be written as like this. Okay, so your del dot f will be I with I, j with j, k with dot k. So that will give you df1 by dx, correct? df1 by dx, df2 by dx, df3 by dx. So curl del cross f is nothing but your del is here cross f. So this can be written as ijk d by dx, d by dy, d by dz, your f1, f2, f3. So final answer will be a vector quantity, final answer will be a scalar quantity. This is for div and this is for curl. So very important problem, we are going to find out the divergence and curl. So del dot r we are going to find out, then del cross r. Of course r is a position vector. R vector equal to xi plus yj plus zk. So now div r, we will find out div r, del dot r. So expression for del is given by this, and your r is the position vector, the expression for r vector is given by this. So now I dot I will give you 1. So we have partial dx by dx, correct? So here it is x. So dx by dx answer will be 1. Similarly dy by dy answer will be 1. dy by dz answer will be 1. So 1 plus 1 plus 1 that will give you. So div dot r answer is 3. Very very important one more question. Okay, often this question will be asked. Del dot r which is equal to what is the answer? So you have to say the answer as del dot r equal to 3. So now let us find out del cross r. So del cross r can be written as ijk with a determinant d by dx, d by dy, d by partial d by dz, x, y, z. And of course we know the matrix multiplication, we know already. So we have I vector d by dy z, and this must be d by dz y. So this can be written as minus, see minus can be written as like this. Okay, minus. So we have, as I said just now, dz by dy. See, dz by dy. There's a mistake here. Dy by dz, correct? Minus dy by dz. So dy by dz. So this must be y. Come on. See, for I we have dz by dy. So dz by dy. Correct? Dz by dy. So here x is written. Actually it should be y. So dz by dy minus the second one is dy by dz. So dy by dz. So here z component is there. Here x is here. With respect to x only you are going to differentiate. So answer is 0. If it is x only you can differentiate. Here z is there. So answer is 0. Here you are going to differentiate with respect to z. But here it is y is there. So answer is 0. See, is it okay? So 0, here also 0, here also 0, here also 0. So it must be y. Don't forget. So final answer will be 0. So del cross r will be always 0. Very, very important one more question. So del dot r equals 0 and del cross r equals always, del dot r equals 3, del cross r equals 0. Okay, very important one more question. Okay. Now let us solve del dot 1 by r vector. Okay, let us solve del dot 1 by r vector. Here del is given by this expression, and of course we know r is a position vector, and mod r is given by this, so r squared is given by this. So we know already. Now let us calculate partial d by dx. So for that, what we are going to do is just to differentiate with respect to x first. So when you are going to differentiate with respect to x first, you have 2r dr by dx, which is equal to 2x. So your dr by dx equal to 2 will get cancelled. You have x by r. So we have del dot 1 by r, del dot 1 by r. So that will give you, your del is here, 1 by r is here, and r vector is here. Okay. So so we have now x by r I vector. You multiply these two, x by r I vector, then y by r j vector, z by r k vector. So dot product will give you I dot I will be 1. So we have d by dx of x by r. See, d by dx of x by r plus d by dy of y by r, partial d by dz of z by r. Now this can be written as 1 by r dot x. This can be 1 by r multiplied by y, 1 by r multiplied by z. So when you are going to differentiate, you will have, so same thing, I have written the same thing, same expression I have written. Now keeping this as constant, you will have to differentiate this, plus keeping this as constant, you will have to differentiate this. So this is a product rule. Differentiation of a b is nothing but keep a is constant, you will have to differentiate b, db, plus b is constant, you will have to differentiate a. So the answer will be a db plus b dA. Similarly, you will have to keep this as constant, you will have to differentiate this. Plus keeping this as constant, you will have to differentiate this. So keeping this as constant, 1 by r, differentiating x, that will give you 1. Keeping this as constant, x, differentiate 1 by r. When you are going to differentiate 1 by r, answer will be minus 1 by r squared, dr by dx. Similarly for the y term, keeping this as constant, you will differentiate y with respect to y. So answer is 1 plus y, you will differentiate this, that will give you minus 1 by r squared dr by dy. Similarly, you will have this expression. Now you have 1 by r, I have written 1 by r here. Okay, so this can be written as minus x divided by r squared. What is dr by dx? X by r, we have already found out. See, dr by dx already we have found out. Differentiating will give you this. So x by r. So you have x by r here. Similarly for the next term, 1 by r minus y by r squared, dr by dy will give you y by r. So you have the next term will be 1 by r minus z by r squared, z by r. So 1 by r plus 1 by r plus 1 by r will give you 3 by r. Simple one. See, all are in terms of addition. 1 by r, this 1 by r plus 1 by r will give you 3 by r. Remaining terms minus x squared by r cube. R squared multiplied by r. So r cube. And this will be minus y squared by r cube. And this you will have minus z squared by r cube. So 3 by r. You just pull 1 by r cube out. So that will give you x squared plus y squared plus z squared. So 3 by r squared, 3 by r minus 1 by r cube. And what is this one? This is nothing but your r squared. So 1 by r cube multiplied by r squared will give you 1 by r. 3 by r minus 1 by r will give you 2 by r. Okay. So we have find del dot 1 by r dot r vector. The answer is 2 by r. Okay. So find the divergence of vector field A is given. So now earlier we are calculating for the scalar field. Now we are going for the vector field. Vector field is given as this. Okay. So vector field A vector is given as x, y, z, I vector, 3x squared y, j vector plus x, z squared minus y squared z, k vector at the point 2 comma minus 1 1. So we have to find out now div A. Okay, divergence, div A. So del dot A. Okay, earlier it was like a scalar field. Okay, del A, del F, del phi. Now it's a vector field. So you have to differentiate. Okay, so del dot A vector. So del dot A vector, as usual, we know already. You have to differentiate first with respect to x, with respect to y, with respect to z. So we are going to differentiate with respect to x will give you. So you have d by dx, x, y, z, then d by dy, the second term, d by dz, the last term. So when you are going to differentiate with respect to x will give you y, z. When you are going to differentiate with respect to y will give you 3x squared. Correct? When you are going to differentiate this, we have both the terms z is there. So we have x2z minus y squared, minus y squared. Now at the point del dot A at the point 2 comma minus 1 comma 1. So instead of y you have to substitute minus 1. Instead of z you have to substitute 1. So when you are going to substitute you will have minus 1 here. This must be 4 multiplied by 3, that will give you 12. And this must be 4 minus 1. And we have 12 plus 4 16 minus 2 will give you 14. So del dot A at the point 2 comma minus 1 comma 1 will give you 14. So what if del dot A, the answer will be in terms of scalar. So 14 is a scalar. So divergence of A vector field, the answer is a scalar. Okay, you have only 14. Now vector field is given as this, and we are going to find out curl F and div curl F. We are going to find out. So first we will find out now curl F. Curl F formula will be del cross F. So you have I, j, k, partial d by dx, d by dy, d by dz, and you have I term is here, and you have jth component is here, kth component is here. Okay. Now, as usual, so your d by dy z cube. So here with respect to y, you will have to differentiate. Correct? But z cube is there. So answer is 0. Minus d by dz, and here with respect to z is there. Here y cube is there. Answer is 0. Similarly, for all the other terms, it will be 0. So your del cross f equal to 0. So curl f equal to 0. Next one is div of curl f. So div of curl f. Del cross f already we have found out. 0 I vector, 0 j vector, 0 k vector. Now what is asked? Div of curl f. So del dot del cross f. Is it okay? See here div curl f. This is your div. Del dot del cross f. Del dot del cross f. Del cross f already we found out this. What is expression for del? Del is given by this. Now this dot with this. So answer will be 0 0 0. So your del dot del cross f equal to 0. Very important one more question. Often this one will appear. Del dot del cross f. What is the answer? So answer is 0. Del dot del cross f will be 0 always. Okay, now we will go for the next problem. Div f and curl f. Okay, f is given as this. F is gradient field. So very important one, f equals minus del f. Most probably you would have learned in physics. F equal to del f. So similarly here also f equals gradient field. So f equal to gradient x cube plus y cube plus z cube minus 3xyz. So instead of gradient you can write del. Okay, del. So del can be expressed as this, and you have this function. Okay, you have this function, correct? F equals del f. So del f. Okay, so you have del is here, and this function you can write this one. Now you can write, you have to differentiate with respect to x. So when you are going to differentiate, you can have f, so which is nothing but 3x squared minus 3yz, correct? So 3x squared, this will be 0, this will be 0, and this will have minus 3yz times I. When you are going to differentiate with respect to y, will give you 0, this will be 3y squared, 0, and this will become minus 3xzj. And when you are going to differentiate with respect to z, will give you 0, 0, 3z squared minus 3xy times k vector. What is asked? Find div f and curl f. Okay, so we have found out now f. What is div f? Div is nothing but del dot f. The expression for del. Already we have found out f. So del dot f. Now with respect to see I with I, j with k, k with k. So very important thing is here dot is here. Here there is no dot here. We have to differentiate these two. This is del phi, gradient phi. So there is no dot here. If there is no dot, you have to go with totally. See, you have to differentiate totally. Whereas here it dot is here. So I dot I will be 1, j dot j will be 1, k dot k will be 1. All the other terms will become 0. So very important thing. So d by dx of 3x squared minus 3yz. When I am going to differentiate with respect to x, that will give you 6x. This becomes 0. When I am going to differentiate this, that will give you 6y. When I am going to differentiate this, that will give you 6z. So del dot f we have found out. Now del dot f. So del dot f equal to 6x plus 6y plus 6z. Taking 6 as common, so 6 multiplied by x plus y plus z. We can write. Now what is asked? Del cross f is asked. See, del cross curl f is asked. So earlier we found out div f, del dot f. Now we are going to find out curl f. So del cross f. I, j, k, your del is given as this and f is given as this. So as usual, your I will be partial d by dy of 3z squared minus 3xy. See, 3z squared minus 3xy minus d by dz of 3y squared minus 3xz. Okay, and similarly for the next term and similarly for the last term. So when you are going to differentiate this with respect to y, that will give you 0 here, correct? So this becomes 0. This becomes minus 3y minus 3x. With respect to y we have to do. So minus 3y, so minus 3x. And what we are going to differentiate with respect to z, that will give you, this becomes 0. This becomes minus 3x. Already one minus is there, so this becomes plus. So minus 3x plus 3x, that will be 0. So similarly, you can have minus 3y plus 3y. Similarly, the last term will be minus 3z plus 3z. So answer will be 0. So del cross f equal to 0. So we have found out now. So we have found out div f as well as curl f if f is given as this. Find a very important problem. So very important problem. Find a. In the expression a is here. In the expression we are going to find out a. Provided is solenoidal. See, solenoidal. Solenoidal means it's a vector field. It's a vector field in which the divergence is 0. That is del dot phi equal to 0. For all solenoid, divergence will be 0 at all points. This means the field has no source, no sink, and the flux entering a small volume is equal to the flux which is going outside. A common example will be magnetic field, as I said earlier, where the divergence is always will be 0 for any magnetic flux. So indicating there is no monopole, there is no south pole or there is no north pole. Combined together we have magnetic field will exist. So magnetic field will exist for two poles, south pole and north pole. For any magnet there must be a south pole and a north pole. We can't have any separate poles. So it clearly says that del dot F equal to 0. So del dot F equal to 0 means it's a solenoidal. Okay, solenoidal. So del dot F equal to 0. So del expression for del, your expression for F. F is given as this. So F is given as this. We are going to prove that this must be 0 and we are going to find out the value of A. If it is so, we are going to find out the value of A. So you have del is here, F is here. So as usual, you have partial d by dx of 3x minus 2y plus z. Partial d by dy of this term. Partial d by dz of this term. So when I am going to differentiate, that will give you 3, correct? This becomes 0, this becomes 0. When I differentiate y, this becomes 0, this becomes plus a. So plus a is here. This becomes 0. When I am going to differentiate this, that will give you with respect to z. So 0, 0 plus 2. See 3 plus a plus 2 which is equal to 0. 5 plus a equal to 0. So a must be minus 5. So we have found out the value of a provided this is solenoidal. For any solenoidal, this condition should be satisfied. Very, very important one. Okay. Now, D is given as this. Solenoidal. It's saying that it's solenoidal. Find the value of lambda. Where is lambda? Lambda is here. So we are going to find out lambda. So we found out A now. Just now. We are going to find out now lambda. Provided this is solenoidal. For solenoidal, del dot V equal to 0. For any solenoidal, del dot V equal to 0. If it is so, this is del, this is your V, which is equal to 0. So as usual, d by dx of x plus y, d by dy of y minus 2z plus d by dz of x plus lambda z. So we are going to differentiate with respect to x here. So 1. This becomes 0. This becomes 1. This becomes 0. This becomes lambda. So you have 2 plus lambda. Lambda equals minus 2. So we have found out the value of lambda. Okay. Show that F equals y z I plus z x j plus x y k is irrotational. To be irrotational, this condition should be satisfied. Del cross F equals 0. For solenoidal, this condition should be 0. Del dot V equals 0. For irrotational, del cross F equal to 0. What is the definition for irrotational? An irrotational vector field is a vector field whose curl is 0. Curl is 0, rotation. It means the field does not exhibit any rotational motion or swirling patterns. This is expressed as del cross F equal to 0, where F is the vector field. So your del cross F equal to 0 for any irrotational. Del dot V equal to 0 for any solenoidal. So del cross F, you have del cross F can be expressed as the determinant of this. So we have as usual d by dy times xy, we have written minus d by dz times xz. So the second term will be this one and third term will be this. So when I am going to differentiate, that will give you, this will give you x, see x. When I am going to differentiate, this will give you again x, see x minus x, and this will be y minus y, and this will be z minus z. So 0i minus 0j minus 0k. So you have del cross F equal to 0. So if any F is any continuously differentiable vector point function, then curl F equal to 0, then F is said to be irrotational. So for any irrotational, the condition is del cross F must be equal to 0. So del cross F equal to 0. So this is irrotational. Find the constants A and B. Again, this is very important problem. So A and B, we are going to find out A and B and C. We are going to find out all the three constants A, B, C to be irrotational. So what is the condition for irrotational? Del cross F equal to 0. So del cross F, which is equal to, this can be written as determinant of ijk d by dx, d by dy, d by dz, and this with respect to I, and this will be j and this will be k. As usual, so d by dy times 4x plus cy plus 2z. Okay, minus partial d by dz times dx minus 3y minus z. Similarly, we can go for this second term, third term, and you are going to differentiate with respect to y. So what will be the answer? This becomes 0, this becomes c. So you have c along. Okay, what about with respect to z? So this becomes 0, this becomes 0, this becomes minus 1. Already 1 minus z, so plus 1. So c plus 1 times I. Similarly, you can go for j. Similarly, you can go for k. Okay, so you have c plus 1, you have to equate like this. So here you have to think that this is 0 vector, it means 0 I vector plus 0 j vector plus 0 k vector. So you have to compare. You have to compare 0 to I vector to I vector that side. So c plus 1, which is equal to 0. So c plus 1 equal to 0. So c will give you minus 1. Similarly for the next one is 4 minus a, correct? So you have a minus is there. So minus 4 minus a will give you 4 minus a equal to 0. So a equals 4. The last one is b minus 2 also, so b equals 2. So we have found out the values of a, b and c, which is nothing but 4, 2 and minus 1. Okay, any doubt? Prove that f equals 2x plus yzi times plus 4y plus zx times j minus 6j minus xy times k is solenoidal as well irrotational. So this vector field is solenoidal as well irrotational. Also find the scalar product of f. For any solenoidal, del dot f equal to 0, we know already. So your del is here, your f is here. So del dot f equal to 0. So you have to prove the answer should be 0. Answer should become 0. So you have now I dot I. So that will give you d by dx 2x plus yz. So you have d by dy 4y plus zx. D by dz 6z minus xy. So when you are going to differentiate with respect to x will give you 2. Differentiate with respect to y, that will give you 4. Differentiate with respect to z, that will give you minus 6. So 6 minus 6, 0. So we have proved that it is a solenoid. See. Now what about irrotational? For irrotational, del cross f equal to 0. So del cross f, we will have to find out del cross f. So as usual, so d by dy times xy minus 6z, d by dz times 4y plus zx minus the second term and third term. So when you are going to differentiate, that will give with respect to y, that will give you x, and when you are going to differentiate z, that will give you x, so minus x. So x minus x will be 0. Similarly for the next one, you have y minus y. Similarly for the last one, that will be z minus z. So del cross f equal to 0. So it implies that hence it is irrotational. Okay, so is solenoidal as well irrotational. And also the last one is we have to find out the scalar product of f. Scalar product of f. Okay, we'll see.